Okay, so where I finished off just now is I was talking about what is in plane and what's out of plane. So over here you can see that, okay, XY plane is in plane and then the rest are out of plane. Now if I'm going to draw the element differently now, okay, so I'm going to draw the element this way now. Yeah, no. Good. So now the element is oriented this way now. Okay, so now this is my, still the same. This is my XY plane. And then the next one, this is my YZ plane. And then the last one, this is our XZ plane. So for this case, the XY plane is out of plane. The YZ plane is also out of plane. And then our XZ plane is our in plane. So can someone please tell me when is it out of plane or when is it in plane? Anyone, please. You don't get this from textbook. I was trying to find out what is in plane, what is out of plane. So can anyone tell me what is the rule, whether is it in plane or out of plane? Anyone? Yes. How do you mean long? So the bigger surface area, right? You're right. Okay. So in plane correspond to the largest surface area. Okay. So you don't get this from books, okay? We were expected to know. I did not know that at all, okay? So now if we go back to our problem over here, right? The biggest face is our what? So this is our so-called our YZ plane, right? This is our what? In plane, right? And then the rest of them, this surface over here is our XZ plane. And this is our out of plane. And then this surface over here, this is our XY plane. And this is also our out of plane. So if you go back to look at the elements we drew, right, you will know our definition of what we call in plane and also what we call out of plane. It's not that difficult, okay, when you see this. But textbooks don't tell you the bigger surface area is in plane or not, okay? So that is frustrating. I tried reading it. Right. So now after knowing what is in plane and out of plane, I'm going to quickly go into a Mohr circle example. We're going to do a 2D Mohr circle. So most of you know 2D Mohr circle either to 3C. Okay, I know some of you have taken 3C quite a while ago. Some of you have taken it recently. So I'm going to still refresh your thought. Okay, so let's start with 2D Mohr circle. Okay, so we are going to have an element. We're going to start from an element. Okay, so this is our element. So this correspond to our x and y. Okay, so over here we have a stress over here. So I'm going to put our stress x. is equal to 30 positive 30, or just put 30. The arrow show whether is it positive or negative already. 30 megapascal. Stress Y is maybe I will call it 10 megapascal. Okay, and then we have a shear, and this corresponds to 20 megapascal. Okay, so what we are going to find is we are going to determine our stress average, our maximum stress, and our stress 1 and 2, which correspond to our principal stress. Our principal stresses. Then we're going to find our principal plane. And then we are going to construct element at its principal plane. Okay. So like what you guys know, whenever I teach Mohr circle, I don't use formulas, right? We construct the circle. So it's important that in your exam, you should have mathematical instruments, okay? Right, so what we do is we label this point X, and this is our point Y. So what we know is stress X is equal to 20 megapascal, sorry, 30 megapascal tensile. Stress Y is equal to 10 megapascal. Shear XY is equal to shear YX, and this is equal to positive 20 megapascal. So what does positive 20 megapascal means? Okay, so I'll bring you quickly to what we mean by positive shear and negative shear. If we look at positive shear, Eugene, come on. Okay, so this is our element. Right, so this is what we mean by positive shear. And I'll draw a center. And then if I draw the other orientation, can you back up to the diagram quickly? Yes. Amanda, you have a question? Okay, Amanda, just want to see the diagram, but not necessarily have a question. Okay. And then if I were to have a negative shear, okay, so this is our element. And this is how negative shear look like. Okay, so again, I will draw the center. Right, first of all, I'll tell you positive and negative shear are both as good or are both as bad. There's no such thing as positive shear is better than what? Negative shear. Okay, so that is the first thing, okay, that I like to drive on. So if you look at the deformation pattern, right, so I'm going to sketch in In red, this is how the element will deform when it's positive shear. Okay, so the deformation look this way for positive shear, and then I'll draw again for negative shear. Yeah, I think I overdid it. Did I? Yeah, I think I did for both sides. Let's do it this way. So you can see the difference in the commodity. So that is for positive shear, and then negative shear deformation pattern this way. And why it look that way is basically you pinch the two arrows, okay? So if you put your fingers at the edges, okay? If you put your fingers at the edges down here, okay, and pinch, this is how the element will deform. So those of you who are live over here, so what I mean by that is you take two of your fingers, you go edge to edge, and you pinch, you get this sort of deformation. Likewise, if it's negative shear, right, you take your fingers from here to here, you pinch the square, your deformation is at that format. It's easier to teach live that way than online, okay? Right. So that is one. So why is this called positive shear and why is it called negative shear? Okay. So if I'm going to zoom in, so if you look at the surface over here, relative to the green line, this is a positive surface, right? Positive area, right? And the shear stress is going up. Usually going up, we call it positive. Coming down is what? Negative, yes or no? So positive and positive give you what? Positive shear. Are we clear? That's the only reason, right? So for the other case, if you look at this surface over here, it is a negative area relative to the centroid or to the transformation, and the arrow is going what? Positive, right? So positive multiplied by negative, you get what? Negative. That's it. Okay, that's why it's called positive shear, and why is it called negative shear? Okay. So now we are clear what is positive shear and what is what? Negative shear now. Okay. So now we are going to construct Mohr circle. Okay. Anyone, any question either online or face to face? Anyone? No? Okay. So the next thing we're going to do is we're going to construct Mohr circle. Okay. Now, on Mohr circle, the x-axis is our normal stress. Okay. So this is our normal stress. And then our y-axis is our shearing stress. Okay. So this is our shearing stress. Now, so at the center is 0. Okay. Then next, I'm going to scale them. I'm going to put a scale on my, so I'll call this 10, 20, 30, 40, and the scale has to be the same in the x-axis and on the y-axis. Okay, so this will be 10, 20, 30, okay, and then this will be minus 10, minus 20, minus 30. Okay. Now on the shear, it's important to write, right, at the top, okay, the top part is element rotation clockwise. So this means element rotation clockwise. At the bottom, element rotation anti-clockwise. Okay. Okay. So one element rotation clockwise, The other one, element rotation, is anti-clockwise. Okay. So we know that we have a normal stress of positive 30. So we draw on the 30 line. Okay. And then we know we have a 10. And then we know that our shear is 20. Now, I understand that it's 20 positive shear, but for the shear, you have to construct both 20 at the top and both the 20 at the bottom. Okay, so this is our stress X line. This is our stress Y line. This is our shear XY line.